This lesson is an intro to the normal distribution, also known as the standard distribution or the bell curve. And it's called the bell curve by a lot of people because of its shape, which resembles kind of a bell like that. And so the normal distribution is all about the idea of central tendency. And by central tendency, what I mean is that most of the data is going to be in the middle of the distribution. So think about the data tends towards the central part of the curve. So let's look at this distribution and think about a distribution curve like this as a area. And so it's going to be the area under the curve represents the probability of a potential outcome. So it ranges from 0 to 1, with 0.5 being right in the middle right there. And you could, if you want to think about it in percentage terms, think about it as 0 to 50 to 100% like that. So a 100% probability on a normal distribution would look like that, where it's all filled up. So there's no probability that anything is outside of the 0 to 1 range. A 50% probability would look like that. Like a 20% probability would look something like that. And then an 80% probability would look something like that. So when you are creating a normal distribution, there is only two measurements you need to form the bell curve or the normal distribution graph using any data set. And those two measurements are going to be the mean and the standard deviation. And so the mean, you should know what the mean is at this point, which is the mean is going to be the arithmetic average of the data set. So you add up the data set and then divide it by how many numbers are in the set. And the standard deviation is going to be the measure of the spread or variance of the data set in relation to the mean. And this is a fairly complex formula that is posted in the video below. For this assignment, you do not need to know the formula. If you want to try out the formula yourself, you can do that, but you can just use the quick calculation that we'll do in the later part of the video. But again, for now, just think of the standard deviation as the spread or variance of the data set. So let's look at a few examples here, and in this case, I'm going to use M for the mean and SD for the standard deviation. So let's say you have a data set where you have a mean of 100 and a standard deviation of 25. So in this case, this is going to be a high standard deviation relative to the mean, because again, 25 is a fairly proportionally large number to 100. And when that happens, that means the data set is very spread apart, so it has a high variance. Let's say with that there's a different data set with the same mean. You have a mean of 100, but your standard deviation is 3. If this is the case, this is a low standard deviation relative to the mean, and this means the data set is very tight. So there's going to be almost all the numbers are going to be very, very close to 100 because the standard deviation is very small relative to the mean. So now let's look at something that's very crucial to the bell curve, and that's going to be the 68, 95, 99.7 rule. And this rule holds true for any normal distribution that is ever created. So what this means is that 68% of the data is always going to be between standard deviation 1 and negative 1. 95% of the data will be in between standard deviation 2 and negative 2, and 99.7% of the data is going to be in between standard deviation 3 and negative 3. So let's look at what that actually means visually. So here's your bell curve, and let's say our mean is always going to be right down the center. It's always going to be the exact center of your normal distribution. And then the standard deviations are going to be right here, and here's standard deviation 1, standard deviation negative 1, and the standard deviations are always equally far apart. So standard deviation 2 and negative 2 are going to be the same distance away from standard deviation 1 is from the mean. And then the same thing for standard deviation 3 and standard deviation negative 3. And the negative just means it's on the left side of the mean or the negative side, and standard deviation, the positive, means it's just on the positive or the right side. So again, let's take a look at that rule. So in the 68, 95, 99, 7 rule, we know that 68% of the data is going to be in between standard deviation 1 and negative 1. And then the second part of that rule is the 95. So the 95 means that 95% of the data is going to be in between standard deviation 2 and negative 2. And then the last one, 99.7, that means that 99.7% of the data is going to be in between standard deviation negative 3 and standard deviation 3. And this doesn't matter what the numbers are of the mean or standard deviation, this rule always holds true. So let's take a look at an example with actual numbers here. And let's say that we have a mean of 20 in our data set, and the data set has a standard deviation of 2. So again, the first thing is that the mean is going to be right in the middle right here. So there's the mean. And then to do the standard deviations, so here's standard deviation 1 and -1, standard deviation 2 and -2, and standard deviation 3 and -3. So to find these, so let's do standard deviation 1, -1 first. So if the mean's 20, on the positive side, you're just going to add 2 to that because standard deviation is 2. So 20 plus 2 is going to be 22. Now on the minus side, you're going to subtract the standard deviation. So 20 minus 2 is going to give us 18. And so with that rule, we know that 68% of the data is going to be in between 18 and 22 on this graph. So now let's go standard deviation 2 and -2, and we're going to follow that same rule. So you're just going to add 2 on the positive side and subtract 2 on the negative. So 22 plus 2 is going to give us standard deviation 2 of 24, and then 18 minus 2 is going to give us a standard deviation -2 of 16. And we know that 95% of the data is going to be in between 16 and 24 now. So let's do the same thing for the thirds. So we're going to add 2 to 24 for standard deviation 3. Then we're going to subtract 2 to 16. So that's going to give us a standard deviation -3 of 14 and +3 of 26. And we know that 99.7% of the data is going to be in between 14 and 26. So before we move forward, it's good to ask this question: what is the point of a bell curve? And so the true point of a bell curve is to take a small amount of data and try to create a probability distribution for a larger population. So you can make a very high probability prediction graph based off a small amount of data. So the idea is that you're essentially taking a frequency table like this and you're mapping on a normal distribution to it. And the more data that you have, obviously, the more accurate your distribution curve will get, and the higher the likelihood that your predictions are going to be accurate. So again, just always think that the extremes are the rarest or least occurring. So if you have a frequency table of height of US men, and again, these bars just represent a number in this range. So the idea is that you would take this data and then you could actually put a bell curve that you could use for the entire population. So again, that answers the question: what is the point of a bell curve? Take a small amount of data and try to create a probability distribution for a larger population. So let's do an example, and this is what you'll actually be doing in your assignment. So this is going to be obviously different data, different numbers, but this is the same idea. So a district is trying to predict the results of 5,000 student test scores from the results of just 20 random tests that they pulled. So let's say these are the scores right there that they pulled from the test. And so what you're going to be doing is, first, you're going to find the mean. Then you're going to find the standard deviation. And you can find the standard deviation and the mean by hand if you would like, or you could use the Desmos calculators. It doesn't matter. As long as you have the two, that's all you need. And then the third thing you're going to do is you're going to use the mean and standard deviation to create a bell curve graph. And then once you have your bell curve, what you're going to do is you're going to answer two types of questions. The first is going to be a probability a student scored between a certain range. So you're going to find how to find a range of values using this distribution. And then the second thing you're going to do is probability the student scored higher or lower than a certain score. So you're going to learn how to do where you want something that's higher than or something that's lower than. And we're going to do all of this in Desmos. All right, so we're in Desmos here, and what we're going to do is we're going to use the functions. You can find the mean and the standard deviation on your own, or you can use these functions, but you will need to use Desmos for the bell curve part. So again, first let's find the mean using Desmos. So again, I'm going to go down to functions, and then it brings you here, and you want to scroll down to statistics where it says mean, and then you want to paste your data in there right there. And so there's our mean, 57.85 in that function. So again, there's our mean right there. Now we're going to do the same thing to find the standard deviation. Again, I have my data already copied to my clipboard. So I'm going to go down, and we want to go to stdev is the function for standard deviation. And again, Desmos, it's pre-programmed in, so it will do the calculation for you. And again, if you want to challenge yourself and try it yourself, I do recommend it, but you don't have to. And there's our standard deviation. So this is a high standard deviation relative to the mean because, again, the data is very spread out here. So now that we have our mean and standard deviation, and you can round this, so let's just use 22.46 for our standard deviation, and we'll go 57.85 for our mean. So now we have everything we need to create our normal distribution. And so again, we're going to go to functions, and you want to go down to distributions, and it's the first one, normal dist. And so always the mean goes first. So you're going to put in the two numbers, and you have to separate them by a comma. So our mean is 57.85. And that's our mean. And now our comma, we put in a comma, and now we're going to put in our standard deviation of 22.46. All right, and so it's not going to do anything at first. You're not going to really see anything. It's not going to make sense. You have to click this zoom fit button. So again, don't be worried if you type it in and nothing's there. As long as you see something here, that means you did it right. But you got to click this zoom fit magnifying glass right here, and that will take you to it. So again, if you see here, if you type in x equals 57.85, there's our mean. It goes right down the center of it. But you don't need that there. You can leave it if you want. But what we want to do to find these ranges, so the first question is, what is the probability a student scored between 20 and 60? So you're going to click find cumulative probability range, and when you click it automatically, you see it's at 1, which means the graph is full, right? It's 100% here. And so we want to find the range between 20 and 60. So probability student score between 20 and 60. And so there is a 49.2% chance that a student scored between 20 right here and 60. And if you want to get rid of the mean there. And so then the second question is, what is the probability a student scored higher than 55? So to do that, that means our minimum, we're going to set our maximum to infinity because we know it just has to be higher than that. So this would be the probability a student scored higher than 20. And as you can see, 95% of the data is there. And again, you can kind of just eyeball test it, that you can see 20 right there. So obviously the graph looks full. So again, kind of eyeball test it if that helps you make sense of it. So again, we're going to go the minimum of 55. And what's the probability student scored higher than a 55? And again, I did not make, this is just random, that 55% chance that a student scored higher than 55. And again, bell curves are not always perfect because as you can see here, there is some overlap where it goes into the negatives. And obviously you can't get a negative score on the test. That means 0 would be the lowest score. So they're not perfect, but again, they're just used as measures to try to get as accurate as a prediction as possible. So that is how you do this assignment. I hope this video helped and helped you understand normal